I'm Thierry from the land of chocolates, which is not Switzerland, it's the other land. It's Belgium. And so I brought you chocolates. So you might not understand anything about Conway's law, but you will remember. Oh yeah, Thierry, that was the chocolates, they were good. Right. So, I'm a pretty shy speaker, and this is a horrible situation, and I keep doing it. Right. My pronouns are they, them. And now, let's go. I don't like to talk about myself. It's just uninteresting. Right. So, back in 1968, Melvin Conway formulated a hypothesis that said any organization that designs a system is constrained to produce a design that is a copy of the communication structures of the organization. Now, when Melvin Conway speaks about a system, he really means this in the very broad sense. So this is not limited to software or IT systems. So this might be cars, this might be aircrafts or engines or public transportation systems or telecommunication systems. So like really anything. Could be a factory. Now, what is interesting is that, in fact, around the same time, various people from different communities made a very similar observation that later was called the mirroring principle. And it's not very clear if these people knew about each other and was aware that they did those observations. And so we mainly had the community around organization design and organizations as complex systems, where we have Thomson in 1967 with Organizations in Actions. Now, when I read the book, I realized that Thomson is actually foundational about organization design. I didn't know that. And with the talk of Trond and with the workshop of I'm trying to pronounce your name correctly. Joao? Well, I've made some connections around closed and open systems because before Thomson, there were two thought lines. Like there was the people thinking about closed systems and the people talking about open systems, also called natural systems. And he said like, yeah, no, we don't need to differentiate. We need both in an organization. So he brought both into his thinking. And then we have Galbraith in 1974. Besides organizations, we also have then the community that is around product design and products as complex systems, where the focus is on designing the product for efficient task completion, where with organization design, the focus is on organizing organizations in such a way that tasks can be completed efficiently. Now, in product design, we have Alexander in 1964. This one I haven't read yet. It's also a book. And, well, that's the reason why I haven't read it. Well, reading a book and reading a paper is, well, two different things. Takes more time. And then we have Partners in 1972. But both communities took their inspiration from Simon, the architecture of complex systems, and he introduced the idea of partitioning complex problems to solve problems, to more easily solve complex problems. And so the idea is to, well, split a complex problems into a series of linked sub-problems, which is more easy to solve. Now, Partners is quite interesting also. So on the criteria to be used in decomposing systems into modules, for some reason I can't memorize this title. So he introduces the idea of information hiding as a means of tackling complexity, which later becomes abstraction layers like we know them. And information hiding is quite foundational for the mirroring principle, because now we can split a technical system into modules that are each informationally isolated from each other, allowing teams, distinct teams, to work independently from each other on different modules. And so we get to a situation where we can have a mapping from technical modules to design teams. So this means that the mirroring principle can be formulated in terms of structural correspondence between two structures. We have the organizational structure and we have the technical structure. And so the organizational ties in firms and in companies, well, will correspond to the technical dependencies of the work being performed. Now, all this thinking has been recently, 2016, summarized in a paper called The Mirroring Hypothesis from Colfer and Baldwin. Now, all the references that I mention are listed at the end of this slide deck that you won't see. So it's 3 slides with all the references. So, and the slide deck will be available. Now, in recent years, this idea of this mirroring principle, well, resurfaced as a guiding principle to organize teams. Although there are still quite some people that are rather skeptical about this idea. Now, there is a little story behind Melvin Conway's paper that he also mentions on his website. Like, he first tried to submit to Harvard Business Review, but they rejected the paper on the grounds that there is no proof for the thesis. And so he sent it to Datamation, which was a major IT magazine back then, and Datamation then finally published it in April 1968. But by now, there has been, well, quite some academic research that supports the thesis. And the first one was in 2004 from Souza and friends, where they looked at the design process of a commercial aircraft jet engine at Pratt and Whitney. And so they looked at the organizational problems that exist at the boundaries of the components inside the jet engine. So whether there is a misalignment between the interfaces of the jet engine components and the design team boundaries. And their conclusion was that, well, we can provide empirical evidence that product ambiguity exists, and it is most likely to exist around the organizational and system boundaries. Meaning there is a great likelihood that some of the system component interfaces will not be covered by design team interactions, which can lead to major setbacks involving significant rework that can be extremely expensive. And in the paper, they refer to 2 such major setbacks that happened during the design process. So what they are essentially saying is that if there is a misalignment between the structure of the organization and the architecture of the product, the system, well, there will be problems. Then in 2007, we have a research done by Gokpina and friends, where they looked at the design of cars inside the automotive industry. And their conclusion was that mismatches between product architecture and organizational structure are positively associated with, with quality problems. So again, what they are saying is, if there is a misalignment between the structure of the organization and the architecture of the product, there will be problems. Then in 2012, we have the first empirical evidence for the software industry provided by research from McCormick and friends. And one of their findings is that products tend to mirror the structure of the organization in which they are being developed. And to prove this thesis, they compared open source software with closed source software, based on the idea that the open source community is a loosely coupled organization because individual contributors have diverse goals, belong to different organizations, are working in different locations and in different time zones, and don't have formal authority on the development process. Whereas a closed source organization is a tightly coupled organization because it consists of smaller teams that are co-located, share common goals, and that have formal decision-making authority over the development process. So essentially, they explored whether organization with distinctly different forms will produce products with distinctly different architecture. And so they found out that a loosely coupled organization, like the open source, will produce products with an architecture that is far more modular than a closed source organization like a commercial firm. And this is somehow confirming the findings from partners regarding information hiding, because the information hiding, well, allows individual contributors to work independently from each other. Right. Now, over the years, we had various different people that reformulated Conway's law in different ways. And each rewording, each paraphrase brings new insights and new consequences regarding the law. But sometimes they give the impression that, well, they actually contradict each other, although they all come to similar conclusions. Now, this was pretty confusing when starting to write this presentation, and didn't really help to come to a compelling story. Whatever. Now, in 1979, we have Jordan and Constantine that reformulated the law more firmly. Systems are isomorphic to the organization. And isomorphism means corresponding or similar in form and relations, being the same or similar in structure or shape or form. So it pushes the idea that any system that will be designed by the organization will be shaped according to the structure of the organization. So this means the organization drives the system design. Now, this has an interesting consequence. If you have two subsystems that are being designed by two distinct design teams, and those two design teams do not communicate with each other, well, by definition, those two subsystems will not communicate with each other. But there is more. There's also a mathematical definition for isomorphism. It is a structure-preserving mapping. It is actually a one-to-one correspondence between two structures. Now, this indicates that we cannot ever have an organization where two or more components from the technical system that maps to a single unit, well, a single team inside the organization because of this one-to-one correspondence. And so this means that no single team can be responsible for more than one service. Now, this is quite a strong expression of the law. Way more stronger than how Conway formulated his thesis. Because, well, Conway speaks about homomorphism in his paper. And homomorphism is a more relaxed version of isomorphism. It is a structure-preserving mapping between two structures, but it is not a one-to-one relation. And this is what makes Conway's law. It is this homomorphic force. It is this power of one system, one structure to bring itself about onto another system or another structure. And the force creates the structure and the force preserves the structure. So this means that if we have 4 teams maintaining a compiler, well, the result will be a 4-pass compiler. But over time, we will find that the compiler will work back on the organization. And so the organization cannot have one team maintaining the compiler anymore. They need those 4 teams to maintain the compiler. And this is why COBOL organizations find it very difficult to do anything approaching agile, because the organization is in harmony with the software. They created the software, but over time, the software reasserts itself onto the organization. And if we try to change the organization, the software won't let this happen. Now, because this is not a one-to-one mapping, a homomorphism from an organization towards a system does not require that every component or every part of the organization maps with a single component of the system. And so we can have a single team that is responsible for more than one service. In 1996, we have Eric Raymond from the seminal essay, The Cathedral and the Bazaar. Anyone read The Cathedral and the Bazaar? All right, so The Cathedral and the Bazaar is an essay where Eric Raymond compares open source software development with enterprise software development. It's like from back in the early 2000s. Now, Eric Raymond rephrased the law by saying organization and systems are congruent. Congruent means an agreement or in harmony, identical in form, exactly equal in shape and size. So this reinforces this homomorphic force, so this structure-preserving mapping between the structure of the organization and the structure of the system architecture. And Conway exemplifies this homomorphic force in his paper by mentioning the COBOL and ALGOL compiler example. So he refers to a contract research organization that was asked to design a COBOL compiler and an ALGOL compiler. And the organization consisted of 8 people. So after some initial estimations on difficulties and timings, they decide to assign 5 people to the COBOL compiler and 3 people to the ALGOL compiler. So the result was that, well, the COBOL compiler ran in 5 passes and the ALGOL compiler ran in 3 passes, obviously. In 2004, we have Coplin and Harrison who reworded the law by saying the organization must be compatible with the system, and compatible means able to exist together without conflict, without problems. Now, this is interesting because Jordan and Constantine said the system is isomorphic to the organization, so the organization drives the system design, where here Coplin and Harrison are saying quite the opposite. It is more likely that the system architecture drives the structure of the organization, and if they are not in harmony, the system will impose a structure on the organization so that the organization is again aligned with the system. Where Raymond still stays somewhere in the middle, like organization and system are congruent. They are in harmony, in correspondence. But Coplin and Harrison can also be interpreted differently. It is the organization that imposes its will on the system architecture. So the organization acts as a force on the initial system design, that is the greenfield design. The structure of the organization defines the possible system designs that we have at our disposal. And this is also what Conway says at the start of his paper. The very act of organizing means that certain design decisions have already been made. But once the system grows, the system design matures, the system becomes long-lived, gains expressions in couplings that constrain, it is now the system design that acts as a force on the organization, and this closes the option space we have to design the structure of our organization. And so this brings us to the reverse Conway's law. So for long-lived organizations with long-lived systems, it is the system that imposes itself on the organization. And this is what happens with COBOL organizations. So if we have a 3-tier system consisting of a front-end team, a back-end team, and a database team, consisting of a front-end, a back-end, and a database, well, chances are we will find in the organization a front-end team, a back-end team, and a database team. So the system mirrors itself back onto the organization. Now, this is what happens with long-lived organizations having long-lived systems. this might be a bit expensive, might not be the most efficient way of working, but hey, it works. And this is fine as long as it allows us to continue and to move forward. Now, where all problems start is when management decides to reorganize and decides to send one layer to another country, or decides, oh, we don't need the database team anymore. Well, the database is done, isn't it? Or they decide to reorganize in such a way that the organization is not compatible anymore with the system, but the system won't allow this, and it will work back on the organization. And it's not pretty. And in this regard, Matthias Verhaas quoted one CTO who said, oh yeah, we reorganized, but well, it seems the system didn't get the memo. Ha! And this, well, again, this is essentially what happens with long-lived organizations with rigid, long-lived systems. The system, well, we cannot just reorganize. It doesn't work. And this is the result of this homomorphic force, this structure-preserving mapping between the force creates the structure, but it also preserves this structure. So over time, the system reasserts itself on the organization. And so both sides are going to push on each other. And this is why the inverse Conway's maneuver falls short, or more precisely, people have the wrong expectations of the inverse Conway's maneuver. Oh, we just need to reorganize and that will solve all of our problems. Yeah, right. No, that won't happen. That is not true, especially not for rigid, long-lived organizations. But still, this brings us to the inverse Conway's maneuver, which has been mentioned for the very first time in 2010 by folks from ThoughtWorks, Johnny Leroy and Matt Simons. So before organizing teams and defining the structure of an organization, we should have a clear understanding of the architecture of the system that we want to achieve. So it all starts from the system, which is somehow repeating Coplin and Harrison, who said the organization must be compatible with the system. It is the system that drives the structure of the organization to ensure that the organization is in harmony with the system. Now, this works for greenfield and for flexible systems because, well, the organization acts as a force on the initial design of the system. And so the structure of the organization gives us all the possible system designs that we can achieve. However, this does not work for long-lived systems because of the reverse Conway's law. Once the system design matures, the system becomes long-lived, gained expressions and couplings that constrain, while it is now the system design that works as a force on the organization. And so, well, closes the options we have to design the organization. Having said that, it is clear that for greenfield or flexible systems, well, we should architect the organization to architect the system. So, but this means two things. First, if we want separate modules, we need separate teams. So if we have two distinct pieces of functionality, well, we should have two distinct teams that produce two distinct modules, and each team can optimize around its own module. Again, this confirms Parner's with its information hiding. The information hiding allows the teams to work independently from each other on different modules. Now, conversely, if we ram two teams together and bring the code and the modules together, well, the modules and the functionality get intertwined. Second, collective code ownership leads to more integrated teams and to more integrated code. Now, this might be a good thing, but this might also be a bad thing. So if we want the code to be separated because we have two distinct pieces of functionality, well, yes, we want to separate the teams. But if we have lots and lots of layers, lots and lots of superfluous objects, it might be better to bring the teams together and bring the code together, and this will reflect itself in the system design. But the inverse is also true. Drafting the system architecture is already designing the organization. And this is exactly what the inverse Conway's maneuver is all about. Now, as we all know, the initial design is rarely the best. As we work on the system, well, we learn what the relevant architecture could be. So as we move forward, we get feedback, we get new information, so we learn and we adapt. But this has consequences for the organization. So this requires organizational flexibility to come to an effective design. Now, without organizational flexibility, well, we are constrained to produce a system design that is a copy of the real underground communication structures of the organization. Now, be aware, the real underground communication structures of the organization are not necessarily the ones depicted on the traditional organization chart. So people don't limit their communication to the lines on the org chart. No, teams will reach out to whomever they depend on to get their work done. But this also means that incremental software development has consequences. As the system grows, as the software grows, entropy grows. To contain entropy, well, we need to refactor. Many refactoring leads to a significant redesign. So this means that incremental software development, well, will impact the organization because we are redesigning the system. And so it requires growing and designing the organization as the system grows so that the organization stays aligned with the system. And so again, it requires organizational flexibility. So organization and system need to co-evolve together. And Adrian Cockcroft, so the former chief architect from Netflix, who brought Netflix from a DVD renting company to a streaming company, well, he confirmed this in a conversation with Ruth Mellon on Mastodon, where he shared, yeah, well, I think I have seen this at Netflix and at AWS. So on an annual basis, they realign the teams to the new system boundaries. But this creates two imperatives. To keep asking ourselves, is there a better design not available to us because of the organization? And can we change the organization if a better design is found? And Melvin Conway came to the same observation 50 years later, where he said, well, the importance of the law is not so much that every organization is constrained to produce a system that is a copy of the communication structures of the organization. No, the importance of the law is that the organization is keeping us from designing the system we should be building to delight our customers. And if the organization is keeping us from producing the right thing, well, we should have the flexibility to change the organization so that we can come to a more effective design that fits the needs of our users. But that, again, requires organizational flexibility, which is not that easy, especially not for long-lived organizations because of the inverse Conway's law. The system design acts as a force on the organization. Now, because the initial design is never the best one, and because of incremental software development, well, architecture is never done. It's never finished. It's a continuous ongoing thing. And therefore, system architecture is a great source for archaeological research on past enterprise decisions, because changes we are making today need to coexist with changes we've made last year and with the changes that we've made the year before. And so once we take this perspective, well, we stop trying to rip apart the application or our systems and start all over again. No, instead of that, well, we start focusing a lot more on incremental change. And here starts the history of our decisions. Now, if we have managers deciding on teams and deciding on which services are being implemented by which teams, well, we have managers deciding on system architecture, and as such, managers are architects. But also, anyone who claims to be an architect needs both technical and social skills. They need to understand both the people and the work inside the socio-technical framework. So they need to have a say in the structure of the organization, and therefore architects are managers too. Now, anyone who makes decisions on the shape and placement of engineering teams is strongly influencing the system architecture. And so by now it should be clear that structure of the organization and architecture of the system are communicating vessels, and both need to be tackled together by the same group of informed people, that is, managers and architects. All right, now to conclude, start small. Delay staffing for as long as possible, because once we start adding staff, we are adding more communication structures to our organization. We are adding new nodes to the hierarchy of the organization, and so we are adding new nodes to the software. So this grows the software and this impacts the system design. Instead of that, we should start with the smallest team possible and get a small system working. Small system, small team. And then we grow the team with the system as we need. And this is the only way we can control the architecture of our system. The bigger the team is, the more the structure of the organization dictates the structure of our system. The harder it becomes to contain the architecture of the system. So do not start thinking big right from the start, because, well, once we start thinking big, we need to staff. And once we start staffing, then our system grows out of control. Well, because we need to keep people working. So no, instead of that, start small. Probably smaller than we think we need. Thank you. Questions? Chocolates? That's good. Yeah, well, you can do another one. All right. Well, I'm still around till tonight, if you have questions. Yes, over there. Is there a mic?
Hello. Okay. Is the optimal structure of your organization supposed to be the same as the optimal structure of a system?
Ooh. What do you call optimal?
Let's say the most efficient system. Is its structure supposed to be the same as the most efficient structure of the organization?
Well, ideally, I'll explain my current situation. So I'm working for a fintech, 6 years, and we have a team of 6 engineers. Total company size is 15 people. And we have quite a lot of systems that are managed, but they are all managed by the same little group of 6 people since 6 years. So it actually started with 3 people, and then, well, it grew to 6. And during a long time, we didn't hire because we just focused on efficiency, and we grow the business without adding more people, adding more staff. So I would call this the most efficient way of organizing teams. Now, one day, maybe there will be a second team, and then decisions will be made all about, well, which team will handle which system. But that I don't have a crystal ball that will tell, yeah, oh, this will happen. We don't know. Maybe we will take decisions that will be the wrong one, and then we will go back and change. Does that answer your question?
That will do.
All right, there is another one there.
Hello. Once I found out that my colleagues, they needed to understand Conway somehow, and I just had my own read on that. And what I got out of it is, or was that, what Conway said basically is that with time, either the system adapts to the organization layout, communications layout, or otherwise, depending on which one is more flexible. Would you agree with that read, or?
Yeah, depending on how your system is, because, well, as said, rigid systems don't change that easily, and so while you can try to move people around, it's still the same rigid system, and it will take you like a year to change the rigid system. So you are there in the middle. Will be difficult. More questions? One over here.
How do you prevent manager from believing that adding developers will improve the software structure or the delivery speed?
So I'm going to try to rephrase the question. So you're asking how to how to convince managers that we need to hire extra people to improve the system?
That we don't need, because
that we don't need. Yeah, that's a hard one. Yeah, we don't need. Yeah, just add more people. More. Yeah, it doesn't work. How to convince? Because I have more experience, I don't know. Because, well, someone said that in one of the talks. It's based on experience. We know this doesn't work. It's like the mythical man-mont. Adding more people to a late project will make it more late. And I remember when we had the second funding for the fintech, the CEO was going crazy, like, yeah, we need to hire. No. Luckily, they didn't. Probably part of it is hard to find people. Yes.
Thank you.
When an organization starts to change their architecture, and the organization is structured in another way, do you think you can work with virtual teams for a time?
I think it's something incremental, and there's no roadmap for this, and there is no like predictive way to handle this. It's like you do experiments, you try things, and you find out, oh, this seems to work. Oh, this looked a good idea, but actually it's bullshit. But you need this adaptability and this open-mindedness to try things.
Okay, it was a no, yeah.
Yeah, you mentioned in one of your slides that code can act as an sorry, I will not.
Archaeological
yes,
source.
Thank you.
It's a difficult word. I'll give you that.
Thank you very much. Do you have examples, please?
Do I have examples? Yeah. So I manage the infrastructure of the fintech, and I still see code that I'm not really fond on. Like we did the mistake of when migrating to another cloud provider to pool all environments in one account, which is an anti-pattern. And so you end up naming all things prefixed with environment names because, yeah, you need to segregate. At one point, while we migrated the thing to different accounts, but those prefixes are still present. And that's like always a little story. Yeah, well, this is a thing from the past. We need to rename, but renaming is not evident because, well, it needs, well, some infrastructure you can't just rename. It's like destroying, creating a new one. But yeah, you can't do that like that. So that needs, you need to apply expand contract, so bringing up new infrastructure then with the new name, keeping both in, together, running, and then at some point you tear down. It's not the kind of thing you want to start doing because it's not like, oh yeah, I'm going to start this today and tonight it's done. No. Is that an answer? Right. But there are certainly other things. Thank you. Thank you.